Hey there, everyone. My name is Ryan Schul. Welcome to my data science channel. I talk all about predictive analytics, data science, machine learning, artificial intelligence, and things of this nature. I've got a pretty good lesson for you today. And let me just preface this by saying I'm trying to make this YouTube channel a viable means of income for myself. I worked on Wall Street for about 20 years, and I got a little bit tired of the corporate grind and wanted to get away from the 9 to 5 lifestyle. And on Wall Street, when they say 9 to 5, it's not really 9 a.m. to 5 p.m. It's like 9 a.m. to 5 a.m., right? Because you work these extremely long, extended, insane kind of hours. You go home at 5 a.m. and then you get back to the office at 9 a.m. So that's your 9 to 5. It's not 9 a.m. to 5 p.m. It's 9 a.m. to 5 a.m. the next day. Isn't that lovely? So I'd like to get away from all that nonsense and just do YouTube as a full-time gig, and any kind of feedback that I get from you guys is helpful. Any kind of thumbs up, positive comments. You like the channel, that's great. That helps me a lot. Watch the video from the beginning to the end, and subscribe. Right, subscribers are huge. They're called subs. The more subs I get, the better I do, and the more videos I can put out. So hopefully it works. We'll see pretty soon if this is going to take off or not. So the topic today that I want to talk about is probabilistic modeling and compare that to predictive modeling. We're going to use Python. Of course, I use Python for all of my analysis, pretty much 99% at least, maybe more. So what are the similarities and differences between probabilistic modeling and predictive modeling? Probability modeling or probabilistic distribution is basically the bell curve. I'm sure you've seen this. It's shaped like a bell, and it shows you the distribution of data points around the curve. Now, it could be slightly skewed left or right. It could be, it could have kurtosis, so there's peaks and valleys in the curve. But a lot of times it's normal. It could be not normally distributed, and that's fine. But whatever the distribution is, we analyze it, right? Normal is good. If it's not normal, that's fine too. But predictive modeling is basically using machine learning models to predict a specific outcome, right? And examples of probabilistic modeling are Bayesian networks, Markov chains, hidden Markov models, right? And linear regression, random forest, neural networks, things like this sum up predictive modeling. And for probabilistic modeling, we look at risk assessments, anomaly detection, and decisions or decision-making capabilities under uncertainty. Predictive modeling focuses more on stock price prediction, some types of anomaly detection, customer churn modeling, student success prediction, things like that, right? So let's go ahead and look at an example here. I'm going to hit Control-Enter to refresh the data in a cell and create a small data frame. And then based on the data frame here, you will see the distributions of data points underneath certain bell curves or bell-shaped curves. More or less, they're bell-shaped. Sometimes they're not exactly bell-shaped, but you'll see the distribution when the curve is plotted. And then we're going to compare that to a predictive model where we're trying to predict a certain outcome, a dependent variable based on a given input, which is an independent variable. So here's the distributions. You can see the first curve here in the upper left is not bell-shaped at all. The second has a couple peaks. This has 2 peaks and 1 valley. This is 3 peaks and 2 valleys. And this one on the lower right-hand side, sort of the southeast side of the chart, is a little bit more bell-shaped. And you can see here, past claims, this is insurance data, either there's a claim or it's not, right? So 0 or 1, these are binary. Over here, you can see past claims, again, it's binary. That's why you have these peaks. There's a claim or no claim. Over here, we have home value and then age, and the distribution is all over the place. So we have a scatter plot and a couple of distribution plots, right? We see that in the first illustration over here, or the first image over here. So those are probabilistic modelings where we look at a certain probability of outcomes. With a predictive model, we're trying to predict a certain outcome or a certain target based on independent variables. So here I have an empty cars data set. This is one of my favorites because it's very versatile, very scalable, easy to access and easy to use and easy to explain to people too. So we can look at the data set right here. I'm printing a small sample of the data set. We can see miles per gallon, cylinders in a car, displacement of the engine. This is all data relevant to a car's performance or car's engine, right? So we're trying to predict miles per gallon right here. This is the target variable based on these independent variables, which is everything else except for miles per gallon. If you look here, you'll see these are the features here of the car. We're trying to predict miles per gallon. So we drop the MPG feature and we are assigning that to the target, right? So when we run this, this is an ordinary least squared model. We're going to look at the predictive capabilities of the model. Okay, so high R squared, so the model is able to make pretty decent predictions. Adjusted R squared is a little bit lower. It's always lower or equal to the R squared, depending on how adjustments are made to those features. The F statistic is okay. It could be higher, right? If this is higher, the F statistic almost guaranteed will be higher. So we want to find a high F statistic, high R squared, and then see what variables over here under the P value, under the P column right here, are statistically significant. So the smaller the better. 0.05 and lower is statistically significant. I don't see any significance over here for P values, and the T values are kind of low too. We want to see 1.96 over here to be significant. That's almost significant. This is kind of low. So if this was under 0.05, it would be significant. If this was greater than 1.96 or less than negative 1.96, that would be significant. But nothing is really significant. That's why we're getting kind of lower R squared. But collectively, everything together does give us an okay R squared. 0.875 is not bad. It's not fantastic, but it's okay. Okay, so the model basically is able to make fairly accurate predictions. About 87.5% of the time the predictions are going to be accurate. So that is a predictive model, right? We're trying to predict a certain outcome. That's a machine learning model. Probabilistic model is just looking at the distribution of outcomes under a bell curve and how likely or what's the probability of a certain outcome, right? So probability could be 10%, 20%, 30%, 80%, 90%. Those are the probabilities of a certain outcome. Machine learning is more predictive in its nature, and it's trying to predict a certain outcome, which is the miles per gallon, based on these inputs, which is everything except for miles per gallon. Okay, so hopefully that makes sense. Let me go ahead and build a chart here and show you an example, a visual example of a probabilistic model. Okay, so here we're looking at home insurance payout estimator, and I create a little dashboard here. That's all this is. And we have home value over here. As you adjust these numbers down here, the chart and the lower part of the screen is going to be adjusted. So here we have the average payout. This vertical line shows us that the average payout is about $12,700. If the home value is higher, the payout is going to be higher because you have more stuff that you're insuring and a higher value of stuff in your home, whatever the stuff is, right? The bigger home, probably the more likely you're going to fill it with a bunch of things. And the smaller the home, probably smaller square footage, the less insurance you need and the less likely you are to make a claim just because the house is smaller and you have less things, or the value of your things is just less. So the predicted claim is going to be less, right? But as you increase this more and more, the likelihood of a high claim being submitted to the insurance company and paid out by the insurance company is higher as the home value increases. The location has a slight effect on the probability of a claim being paid out. And I guess that's significant, right? Like if you live in New York City, it doesn't say what this market is. I just kind of like quickly threw this together. If this is New York City and you have a claim, probably the home value is more expensive and the things in your house is probably more expensive just because the cost of living in New York is more expensive. If this location is maybe down south or in the Midwest, maybe the payout of the insurance claim is going to be less just because the house is worth less and you have less stuff in your house, so the claim is going to be less, right? So that's a probabilistic outcome. And again, machine learning is more of a predictive type of model. Here we have an XGB regressor, so extreme gradient boost regressor. We saw it before in the OLS model, ordinary least squared. The R squared is about, 0.875? I think that's what it was. In this model, the prediction is a little bit less accurate, about 81% of the time it's accurate. Previously, it was accurate about 87% of the time. So different model, different precision in terms of the predictive capabilities of the model. Let's look at one more probabilistic model scenario, right? So again, we're looking at the distribution around a bell-shaped curve, or somewhat bell-shaped. That doesn't have to be, you can see peaks and valleys in the curve. Doesn't have to be bell-shaped, but that's kind of what we would expect. And if it's not, it's totally fine. It is what it is. But the bell-shaped curve is like the classic distribution where most of the outliers or most of the data points, not the outliers, most of the data points will be under the middle of the curve, and then the outliers will be to the left or to the right of the curve. All right, so we have somewhat different distribution. Before we saw 2 peaks and then 3. Now we see 2 peaks, kind of like a flat plateau here in the middle. Then we see kind of 2 peaks again. This is measuring chronic disease. The last example was around insurance claims. This is the chronic disease and life expectancy based on smoker, non-smoker, number of hours of exercise or frequency of exercise, and then the chronic disease flag being triggered, yes or no. So that would be a probabilistic type of outcome here, and I create a small little dashboard again using the data from this previous example, the probabilistic modeling example. Here we can say if we increase the life expectancy here to 63 or go up to like 70, and we say this person is a non-smoker, we can say probably they're going to live to be about 85.3. If this person is a smoker, 71.2. So it cuts off 12 years of your life, right? If you're a smoker versus non-smoker. Oh my God, 22 years of your life. I take that back. Okay, smoker. Oh, something didn't refresh. Let me do this one more time. 80.5. Oh, you know, I think it's somewhat random too. Okay, it's kind of random. When it's recalculating this, it's a little bit random. But you can see, like a non-smoker on average is going to live longer than a smoker, right? And if you have no chronic disease, you have a longer life expectancy than chronic disease, 71 years here, 78.8. And then, you know, the degree of smoking, if you're a light smoker, probably your life expectancy is a little bit longer. If you're a heavy smoker, probably your life expectancy is a little bit less, right? This is common sense. It's just intuition. So let's look at one more example. We saw 2 probabilistic examples. Let's look at one of a predictive modeling example. We saw 1. Let's look at one more. So we saw the first, we're trying to predict miles per gallon, right, based on the empty cars data set. So now let's look at an example of insurance, the age of the house, location risk, past claims, property value, and deductible. I just refreshed this, and I'm trying to predict based on these independent variables, anything but a claim. We have the home age, location risk, past claims, property value, and deductible. I'm trying to predict whether or not this person is going to make a claim. So the claim is a dependent variable. This is Y variable. Will the person make an insurance claim based on the age of the home, location risk, past claims, property value, and deductible? And we feed this into the model with 87% accuracy or precision, 0.74% precision for a claim. This is a non-claim. 0 is nothing. 1 is claim. So this is binary, 0 or 1. This is no claim. This is claim. Recall is 0.93, 0.62. F1 score is 0.90 and 0.67. And you can see overall the model is about 89.8%, almost 90% accurate. The RC score is almost 90% accurate. The accuracy for the entire model is 84.5%. You can round up, it's about 85% accurate. So it's able to make accurate predictions about 85% of the time, and it can predict whether or not a claim will be submitted to this insurance company based on all these other features, except for claim, which again is home, age, location risk, past claims, property value, and deductible. So that is the difference between probabilistic modeling, which is the distribution of outcomes, right? The probability of something happening is it 10, 15, 20%? Is it 80 or 90% probability of a chance outcome occurring? Or with a probabilistic model, you're trying to predict a target variable, a Y variable, based on either one or more than one independent variables. Here we have, I believe, 5 independent variables, right? Here's the independent variables. We're trying to predict whether or not a claim will be made. That's a predictive model. And over here, we saw kind of the same thing, a little different scenario, but we're trying to predict miles per gallon based on these independent features over here, right? What is the miles per gallon based on all of these features over here? So that's it, guys. Probabilistic modeling versus predictive modeling. Hopefully that made sense. Hopefully that was useful and beneficial for you. I learned a couple new things when I was putting this together. Hopefully I was able to drop some knowledge on you and you learned a couple new things as well. That's my hope here. So I'm going to wrap it up and I will see you guys in the next video. Take care. Talk to you soon. Bye.